Today we are doing paper 6, variant 2 of year 2024, May, June. Now let's start with question number 3. We have done question number 1 and 2 in the previous video. Now we are doing question number 3 and 4. Question number 3 is chemical analysis question. A student tests two substances, solid H and solution I. Test on solid H. Now solid H is barium carbonate. BaCO3, it's barium carbonate. Complete the expected observations. The student adds an excess of dilute nitric acid to the sample of solid H in a boiling tube and test any gas produced. Now, a student is adding an acid in a substance containing carbonate. So whenever we have a metal carbonate and an acid reacts with it, it always gives carbon dioxide. So the answer will be, if a gas is tested, we will write the answer that a gas is produced which turns lime water milky. Lime water will turn milky or cloudy when this gas is passed through it. And I think the second observation will be, again, the effervescence or bubbles of a gas coming out. Identify the gas made in A1. The gas is carbon dioxide. Next question, the solution produced in A1 is solution J. Student divides solution J into approximately 4 equal portions. Now first we'll see that what is solution J. Here, if we see that the acid is nitric acid, which is reacting with barium carbonate, HNO3. So with HNO3, as there is barium, so barium displaces the hydrogen of an acid and forms a salt barium nitrate. So there is barium nitrate solution plus water plus carbon dioxide. So the solution here is barium nitrate solution. So this is our solution J. So solution J has barium ions and nitrate ions in it. A student carries out a flame test on this. So in a flame test, what will be the color of barium? Let's see in the data sheet. The barium gives light green color. So we'll write here that it gives light green flame. To the second portion of solution J, student adds few drops of acidified potassium manganate. Now, a student adds acidified potassium manganate. So what happens to potassium manganate? As we are adding potassium manganate, and here we have barium nitrate. So barium nitrate means there is nitrate ion and there is barium ion. So if we are adding aqueous potassium manganate, so potassium manganate, this is a test of sulfite ion. As we can see here in the data sheet that a small volume of aqueous potassium manganate and the potassium manganate changes its color from purple to colorless in the presence of sulfite ion. But here we have nitrate. So if we have nitrate ion, so nitrate ion will not decolorize potassium manganate. So it means that we cannot observe anything, so there will be no change in the color of potassium manganate. It will stay the same. Then, to the third portion of solution J, student adds few drops of sulfuric acid. Now, a student is adding sulfuric acid in a solution containing barium ions. Now, if we have barium ions, they react with the sulfate of sulfuric acid and form barium sulfate. And this barium sulfate is white PPT, white precipitates. Here, as we can see, that for the sulfate ions, if we have barium nitrate, see here, that if we have barium nitrate and we have sulfate, then this barium will react with sulfate and form white PPT. So we have to be really careful in seeing the data sheet. So here, white precipitate of barium sulfate will be formed. To the fourth portion of solution J, student adds 1 centimeter cube of nitric acid followed by few drops of barium nitrate. Now, barium nitrate is added and we already have barium nitrate. So, barium nitrate will not react with barium nitrate and hence there will be no change or no reaction. Next, test on solution I. Student divides solution I in two portions. To the first portion of solution I in a boiling tube, add 2 centimeter cube of aqueous sodium hydroxide, warm the mixture, test any gas produced using damp red litmus paper. So we are adding in the solution, whatever is the solution, we are adding sodium hydroxide, and with the addition of sodium hydroxide in that solution I, we are getting a gas which is turning red litmus paper blue. So it might be ammonia, because ammonia is the gas which is weakly basic, and it turns red litmus paper blue. Test number 2 is, to the second portion of solution I in a boiling tube, add 1 centimeter cube of dilute nitric acid followed by few drops of silver nitrate. And white precipitates we are getting. So if we add silver nitrate, we get white precipitates. Now let's see the data sheet. That by adding silver nitrate, we are getting white PPT. So it means it is chloride ion. The negative ion will be chloride. So it means that this is chloride. Now, let's answer the questions. Identify the gas produced in test 1. So the gas is ammonia gas. State what is observed when the gas produced in test 1 is tested using damp blue litmus paper. So this gas is basic, as I said before. So it turns red litmus paper blue. But what happens to the blue litmus paper? It will remain blue. So there will be no change. Or you can write that it will remain blue. Identify the solution I. So solution I would be ammonium chloride, because the ammonium ions will give ammonia gas. So it will be NH4Cl, ammonium chloride. Next, we have question number 4. Bismuth is a metal that has reactivity similar to that of copper. So it means it is low reactive, as copper is also low reactive. So if bismuth has a reactivity similar to copper, so it means bismuth is also low reactive. The ore bismite contains the compound bismuth oxide Bi2O3. Bismuth oxide is insoluble in water and reacts with dilute acid to form an aqueous solution of a salt. The ore bismite contains no other compounds that are insoluble in water. So it means all the compounds, everything in the ore is soluble in water except bismuth oxide. And no other compounds that react with acids to form aqueous solution, or the bismuth oxide reacts with the acid. Describe how would you obtain a sample of bismuth metal starting with a large lump of the ore bismite. You have access to common laboratory apparatus and chemicals. So in this question, if you have bismuth ore and you want to take out bismuth oxide from it, then you have to crush and grind it first by using mortar and pestle. So point number 1 will be crushing and grinding the bismuth ore or bismuth by using mortar and pestle. Now, when we are done with crushing and grinding, we turn it into small pieces. Then after making into small pieces, we will add water. Bismuth oxide is insoluble in water. So after that, we'll filter and wash the residue with distilled water. Because bismuth oxide is insoluble in water, so it will be left in the residue. It will come in the residue. So if we want bismuth oxide, then we will wash the residue with distilled water to make it clean from all impurities. Then when we have the bismuth oxide, we'll heat to melt it because it is insoluble in water. Heat bismuth oxide to melt it. We will turn it into the molten form and then we can perform electrolysis on it. Perform electrolysis to get bismuth metal at cathode. Use inert electrodes. And inert electrodes will be graphite. Use inert graphite electrodes for it. Or apart from this, you can use another option that the first 3 steps are the same. These steps are the same. And instead of these 3 steps, you can use another alternate way. What you can do the displacement reaction on it. Number four, perform displacement reaction with bismuth oxide using carbon. Carbon reduces bismuth oxide and pure bismuth metal will be obtained. So that's how we can do another step. We can do this one. And we can also heat the bismuth first to melt it. This will be our point number 5. This is point number 6. And before that, we can write point number 4 is that heat bismuth oxide to melt it as we did in electrolysis. So we can write any of the method. First of all, we have to crush and grind the ore to get bismuth oxide from it. Bismuth oxide, as it is insoluble in water, will add the water. Bismuth oxide will be insoluble. We can filter it out and we can get the oxide in the residue. After that, we can wash it with distilled water. Then when we have bismuth oxide, we can either perform electrolysis on it or we can do the displacement reaction on it to get the bismuth. So that's it. This was our paper 6, variant 2 of May-June 2024 paper.